been traveling full-time in our 2002 Airstream diesel motorhome for about 5 years now. And a couple of months ago, we had a situation where all of a sudden the 110 volt circuits, 110 volt circuits went out in the motorhome. We were sitting camping in South Dakota. We weren't running anything unusual, but we noticed that the microwave turned off and something else turned off. Oh, I guess it was the television set. But the 12 volt circuits were still lit. So I immediately thought, well, a breaker popped somewhere. And I went outside and took a look at the pedestal at the park, and the breaker indeed had not tripped, and the rig was plugged in. Next step was to open up the basement door and look at my Progressive Industries electrical management system, which monitors incoming voltage and current draw on each leg, and it also checks for errors, any bad grounds, floating neutrals, anything of that sort. And that read 117 volts on each leg, so I knew we had power coming in. Well, where does the power go from there? It goes over to the inverter, but before it goes to the inverter, it goes into our Intelitech brand generator transfer switch, otherwise known as a Genset transfer switch. I opened up the cover off the Intelitech generator transfer switch and saw something that didn't make me too happy, a burnt circuit board. And I could see that there was some damage due to arcing. Well, we were not anywhere where I could get an RV part shipped to me quickly. We were only going to be there a couple more days. And we were in South Dakota. This time it was mid-September, and we were on our way back to Arizona for the winter, scheduled to arrive in Arizona by about November 1st. So I didn't want to have to wait and have a part shipped. So I decided that I would do some hot wiring, for lack of a better word, and take the generator transfer switch out of the circuit. And in order to do that, I didn't care about the generator. We didn't need the generator. We were in a full hookup location. And even when we weren't, we had enough solar power and battery capability that we could run the inverter if we needed to run the coffee maker or the television set or whatever. Everything except for air conditioning, of course. But it's September, October, and that wasn't an issue. So I decided that I would hotwire basically the shore power wiring to the coach. And there's 4 wires. There's a hot leg 1, a hot leg 2, a neutral, and a ground. So I tied those together, hot leg to hot leg, neutral to neutral, and ground to ground, tied those together, and then used, instead of a wire nut, used something called a split bolt. And the split bolt allowed me to make a good solid connection, so I could see what was going on and make sure that I had a good connection there. But what I want to show you today and what I want to explain to you today is how the generator transfer switch actually works. The generator transfer switch controls the function, or performs the function of automatically switching power to the coach from either shore power or generator. And so here's how that function takes place and how that works. So this is the Intelitech, and they call it a Genset automatic transfer switch, or generator set transfer switch. And I'm going to take this opportunity to show you how this works. What this generator transfer switch does is it has these terminal strips down here, and you can see that these 4 screws, the ground, line 1, neutral, and line 2, go to the coach and power the coach. And the power comes from either shore power, the same 4 terminals or the generator. And this control board and these 2 relays are the devices that transfer the power to the coach from either shore power or the generator. And being that mine is defective, I'm going to be replacing this generator set. Now, this is defective due to a high current draw, probably a loose connection. It burned the board, and so this whole assembly needs to be replaced. But I wanted to take this opportunity to explain how this works. These are both relays, and these are what's referred to as double pole, double throw relays. Double pole because there's actually 2 switches on each relay, okay, 2 there and 2 there, and that's because we've got 4 wires. We've got 4 wires to switch. We've got a ground wire, line 1, a neutral, and line 2, okay, and so we've got 4 terminals on the relays, and these are double throw relays because you'll see there's a common actuator in the middle, and then there's a contact on the top. That's the normally closed contact, and there's a contact on the bottom, and that's the normally open contact. Okay, so when these relays are de-energized, like out of the circuit and in your hand, the common actuator is connected to the normally closed contact on all 4 of these, all the way across. So when there's no power applied to these relays, what is connected is shore power to the coach. Shore power to the coach. The generator is out of the circuit. And what happens is then when you fire up the generator, there's a 15-second time delay, which is made up of this little circuit board right here. And this 15-second time delay waits to allow time for your generator to get warmed up to operating speed and operating RPM, and so it's ready to switch. And then at that point, this little circuit board back here allows these 2 relays to be actuated. They'll be actuated, and then what happens is now we're connecting the common this common part to the bottom, to the normally open contacts. Remember, normally open, normally closed, that's if the relay is not in the circuit, if it's in your hand, not energized. So the bottom is normally open, the top is normally closed. Once we activate it, boom, it goes down and transfers power. Okay? So just as a quick review, normally these 2 relays are de-energized, and power is connected from shore power to the coach panel. Once you fire up the generator, you don't have to unplug the shore power. You can just go ahead and fire up the generator, and once you fire up the generator, 15 seconds later, these 2 relays both activate, energize, and switch the coach panel to the generator. They take it away from shore power. Here's shore power position. There's generator position. Shore power position, generator. Okay? So again, we got 4 wires on each terminal strip, and we've got 4 terminals, and we're going to switch all of them. This is the existing Genset transfer switch. The new one, they have revised it a little bit. I'll bring that one over into the picture so you can see the difference. Here's the new one. It still has the timer circuit over here on the left side. You can see it's very similar looking to this timer circuit, okay? And same relays, but now everything's hardwired. No longer are we using a printed circuit board. Everything is connected via hardwire. And the terminal strip down here in the bottom uses Allen screws, hex type screws, which will open up and put the wires in, whereas the other one used slotted screws to put the wire underneath. So why this one failed exactly, I don't know, but it was certainly a high resistance connection, probably due to either excessive current draw or a loose connection.